On one occasion, Millikan used an oil drop of mass 2.54 times 10 to the 5 kilograms with a charge of 3.6 times 10 to the minus 9 coulombs. The plates were 4.8 times 10 to the minus 4 meters apart. Calculate the voltage needed to hold the drop stationary between the two plates. Start by working out the weight force of the oil drop using F equals mg and g equals 9.8 newtons per kilogram. Okay, so we're trying to find the I'm going to start slightly different to how they were suggested. We've got force due to gravity equals mg. We need to balance that force due to the gravity with the force due to the electric field, with the electric field strength times by the charge. So we're told the charge, and we know g, we know the mass, so we can find the force, and we know Q. So we don't know the electric field strength, because if you look at it this way, it's going to be mg equals EQ. So we don't know E, but E, the electric field strength, is the voltage over the distance of separation. So we're trying to find the voltage, which is what we're trying, and D, we're told the plates are a particular distance apart, so we have that. So putting this all together into one equation, we will have mg equals V over D times Q. And we're trying to find V, so we'll rearrange that to be V equals mgd divided by Q. Okay, so we're just going to plug in our numbers and perform a calculation. And I'm not going to do the calculation for you now. In fact, I will. I'll just write down the answer. So the mass, 2.54 times 10 to the 5, times by the gravity, 9.8, times by the distance of separation, 4.8 times 10 to the minus 4, divided by charge, 3.6 times 10 to the minus 9, equals, gives 33.189 volts. Okay, and now this one below asks us to give you an answer to the correct number of significant figures, and it's 2, so it should be just 33 volts, and give a reason, 2SF. The reason is because all of our information, that's 3SF, 2SF, 2SF, and 2SF, the least number of significant figures is our limiting factor, so our final answer has to be to the same number of significant figures as our limiting SF. So the rule is that when you're multiplying or dividing, you use the least SF. When you're adding or subtracting, you use the least number of decimal places.